Hi, I'm Paul Brodie, back in the shop. There's a man behind the camera. His name is Mitch. Thank you. We're working on the AERMACCHI. I ordered, about a week ago, ignition system out of the Czech Republic. The company's name is Vape, V-A-P-E. It must mean something else over there, I'm sure. Anyway, it showed up. Here's some of the pieces. There's other pieces on the bike. I'm going to show you over there. It's a 12-volt system. There's no points. It puts out 150 watts, so that's quite a bit of power. And I like the quality. It's good. How much did it cost? $6.95 US. And then you add on shipping, UPS, customs, tax, so I'm a little over $1,000 in Canadian. I hope it works. So one of the things about the system is that this mounts onto one of the rings on the bike, and the sensor mounts on this. So it's two positions, but you can't micro adjust. So, of course, I looked at the manual, well, the installation. It's made for an AERMACCHI, so it basically bolts right on, which is very nice. And in the instructions, they say, not to modify, do not modify. It voids the warranty and all that. So, of course, the first thing I want to do is to modify it. So here's what used to go onto the old flywheel, and it bolted on, and it doesn't fit anymore. So I cut that off. I made a new one. I need to drill holes on the rotary table, and then I need to drill holes into the flywheel on the ignition. So that's going to get modified. I want to be able to move it. I don't want to have to take off the rotor and then reposition it and put it back on and hope I got it right. So what I'm doing, I made sketches. Mitch is going to show you these. These are all my notes I made yesterday. Tried to be as accurate as possible. So this is the piece that fits like so. And there's a couple little screws. I think they're 4 millimeters. So what I'm going to do is to make an alloy plate. It's going to have slots in it. And then I can move it back and forth and put it exactly where I want. So I need to do the same holes. I've got measurements for everything. So that's going to work. Let's go over and have a quick look at what we have here. Thanks for tuning in. All right, here's the old system. That was the flywheel. It's Suzuki, and I made up an adapter plate, and I thought I was going to do the same thing on this. See how that fits on like that? And then that holds my degree wheel, and I can time it. Because if you just bolt this on, I don't know how you know if the timing is accurate or not. So this guy goes on like that, and I'm going to drill 4 holes and put in 5 mil Allen screws. So there's the flywheel. Comes off. Now what I want to show you is this a Suzuki unit. It's got 4 coils, and this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I think that accounts for the higher output, 150 watts. That's good. And what happened on the old system, you know, George was my friend who wired it up, and he put this through that hole there, which seems to make sense. See that? That's how it came up, and it was part of that wire there. So I can't disconnect that. So I had to cut it, but I'm not going to use it anyway, so I guess it doesn't really make a lot of difference. But why I'm showing that partly is because this is the wire which comes off the new unit. And what I've done is I've routed it all the way back, and then it's going to go up there like that. And if I have to take it off, I just pull it off. I don't have it going through the case, which is kind of a clean look, but if you ever have to do anything, that's a problem. So this is the piece I was showing you. See these little holes right there? That's where it mounts. So the piece that I'm making, it's going to mount on those same holes there. And then the sensor, see how it can either go there or there. It's two positions, and I don't know what that is, like 5 degrees difference or whatever, but if you want to go halfway, you can't. So that's our job for today, is to make up the piece that is a substitute for this, bolts on right there, and then I can adjust. So I think that's a worthy thing to do, because I like to know where my ignition is. I don't want to just guess. So let's get started. We're going to go to the mill, use the rotary table and the digital readout. I've got my drawing, so I have dimensions. And if you haven't subscribed, please do. Okay, let's get going. All right, that worked, I think. So I'm going to work on the slots now. I've got a 5 mil end mill, and what I want to do is to drill some smaller holes so that I don't have to use the whole width of the end mill to cut. Just makes it easier. Okay, we're going to use the end mill now. I'm just pointing down. Oops. Wrong handle, almost the wrong handle. Easy to make mistakes. So I'm just smoothing off the sides of the slot now. What I'm going to do now is just to round this radius here. Going to make that smooth. I'm climb milling now just to make it smooth. And after this I do the inside radius, and then I can cut it out on the bandsaw and tap a couple holes. So outside radius is good, slots look good. I'm gonna change the end mill. I'm gonna put in a 1/4 inch end mill. It's a little stronger. I have to make a series of cuts now with the end mill, and then on the final one, I'll move it up to the correct location, and that'll be good. So here we go. I probably have to take a few cuts here. I'm ramping down now. That should be okay for a first cut. I really did ramp down a lot. Yeah, I'm through. All right, so this is the last cut now. I'm moving the table. Okay, I'm gonna drill and tap 4mm threads. So we use the drill press just to put in the pilot hole or the tap drill hole. I didn't show you this before, but what I did is yesterday I milled the back because it was a little bit on the thick side, because the sensor has to be spaced out a certain amount. So by making this a little less, I get the spacing that I want. Okay, let's go tap. I'm eyeballing this. Once you get it started, then it just goes. It's a spiral point tap. It pushes all the chips. See all the chips coming out the bottom? They're nice taps. They're more expensive than a jobbing tap, but they're nice. It's a 4mm tap, so it's kind of on the small side. You don't want to break a tap. I don't want to break a tap. I'm checking for spacing. 2 holes. Yes, they're fine. So that's basically how the sensor mounts on this. And then on the steel piece, which I'm going to make next, this slides on that, and there's 2 holes that hold it. And the screws I'm going to use is 5mm. Got washers. That's how that works. Goes back and forth in that. The sensor is locked onto those 2 holes there. So far, so good. So what we'll do now is go to the bandsaw. I'm gonna trace a half circle on each end, and we'll cut that out. I'll do all the filing later. Okay, let's go cut that out quickly on the bandsaw. And then we're on to this. This is going to be a little harder because it doesn't machine as easily. And what I need to do is to make a ridge right there that this fits onto, so it's always going around on that. Okay, so that's basically what the piece looks like. I'm happy with that. It's pretty simple. Maybe Vape will want to buy my design. Who knows? I'm not sponsored by them at all or anything. I just bought it because it got recommended to me by someone, a viewer, Steve. So thanks, Steve, for letting me know. It's nice to have something that fits right onto AERMACCHI. Let's go back over here. All right, the first thing we're going to do is to go back to the mill, use the rotary table and the digital readout. These holes here are pretty critical because there's a spacing. It's a countersunk screw, so they really have to be, you can see where they go. Can you see through there? So I have to drill those two holes accurately, and then I also got to drill these holes. Those are the holes that go like that. And then this part here is going to get milled down. It's going to get cut like something like that. So I need to drill the holes first. Can you see that? That's what has to come off. So I need to get the holes done first because it's a lot harder to mark it out when it's cut down like that. Oh, actually this, and then that has to come, that's just a little shoulder. And then this here has to be 100 thou. So that's 100 thou. This is 215 thou. And that gives the height of this. Can you see this here? Can you see it's 315? So what I'm doing is I'm matching this height by the 100 thou there and the 215 thou there. All part of my madness, okay? These holes are spaced at, see right there, I got 1.064. It's kind of accurate. How you get that is to measure the outside, and then you measure the inside, you add them up and divide by 2. So that's all part of my calculations here. So let's go back to the mill and see how this works. That might be hard to mill on the rotary table. Anyway, we'll see. Maybe I just have to go really slow. Check by eye. Okay, that's good. So it's a 5 mil threaded hole, and the trap drill is 4.2 millimeters. Pretty standard. All right, while I got this all set like this, I'm going to put in the 1/4 inch end mill, and I'm going to radius this nicely. And then we'll start to cut it down. It seems pretty stable. There's not a whole lot of vibration, but when I mill the top, I'm going to use a 1/2 inch end mill, so we'll see if that changes. I got a carbide end mill in there, 1/4 inch, 4 flute. Just in case you were wondering, I'm taking about a 10 thou cut. And this is clawing milling, going backwards like that. It makes a smoother cut. Okay. I'm going to see if I can do a 50 thou cut. See what happens. Seems to be working just fine. Oh yeah, this is working quite nicely actually. So I gotta drill some holes, I gotta tap 2 holes, use the bandsaw and cut it off, and then it's lunchtime. So that's what it looks like, just like that. Okay, and I can't file the inside of that, so I got my scraper. Let's see. Oh yeah. So here's the test. This has to fit. It does fit, and you can see how much movement I have back and forth to adjust my timing. The sensor mounts here. It stays put. The holes look like they're in the middle. So that's all good. You know, I have to round the ends, and so I'm gonna tap these 5 mil now after I countersink. This has to be opened up. I don't know why I did the tap drill, because it's a countersink hole. So we'll go over to the drill press. We're getting close. It's exciting. Okay, we're going to tap those 5 mil, and then we'll cut it off, and we're basically done. Anchor lube I use for tapping. This is the moment of truth to see if it fits. I'm hoping everything fits. See, I had to make sure there was enough space, because if not, that's a problem. See these wires? Those go on there, but I'll do that later. So there we go. That's what it looks like. I can adjust my ignition now. That looks good. There, look at that. See, I need a gap of 0.5 millimeter there. So that's easily attainable like that. All right, I think that's a success story. And then like this wire, this is the longer one. That's how it goes. It goes like that. And then hopefully the wire is long enough that I can go. Oh yeah, it's good. Whew. Thank you for watching. We appreciate your support. Mitch and I like coffees. If you buy us coffees, helps us a lot. So stay safe. See you next time.